Okay, so welcome to part two. Now, I asked you to determine which form would be easiest to find first. Now, I'm giving you the zeros. So, in the past, once you've had the zeros and nothing's changed here, once you have the zeros, you want to try and find factored form. So you have zeros of negative 3 over 7 and 1 over 2. So each of these will create a factor in factored form. So the negative 3 over 7 creates a factor of 7x plus 3, and the 0, 1 over 2 creates a factor of 2x minus 1. Okay, I would like you to set up your factors this way so there's no fractions inside inside each factor. And one thing that is often forgotten, but you cannot forget if you want to have an accurate equation, is to solve for the a value, because you can have a million different parabolas that have these two x-intercepts. Only one of them will have this y-intercept. So we're going to sub in the point 0, 6 for the y-intercept to solve for the a value. And again, the reason x is 0 is because it's the y-intercept, so that point's on the y-axis. So we sub in 0 for x, 6 for y. Okay, let's just see where those came from. Okay, and we need to solve for a. So we simplify each bracket, each factor, continue with the algebra, solve for a. We wind up with an equation in factored form right there. Okay, so that's a good start. Now we need to figure out whether we want standard form or vertex form. I'm going to start by doing standard form. You've done some work in previous units going from factored form to standard form, and that was using expanding and simplifying. So to find standard, I'm going to take the equation I just got and expand it and simplify it using an array. So negative 2, 7x plus 3, 2x minus 1. Okay, and I'm going to expand the 7x plus 3, 2x minus 1 in an array. So it gives me 14x squared, 6x, minus 7x, minus 3. So when I put all my like terms together, I get, still my negative 2 carries down from before, and I get 14x squared minus 1x minus 3. Okay, once I finish off my simplifying by multiplying the negative 2 through, I'll get negative 28x squared plus 2x plus 6. Okay, so that should be my equation in standard form. Okay, so now I have 2 of 3 down, and now I need to find vertex form. So this will probably be the trickiest one to find. Now think about, if I want to create vertex form, what do I need? So hopefully the answer that jumps out at you is, to find vertex form, I need to know the vertex. It makes perfect sense. So let's try and find the vertex. Well, to find the vertex, what do we need? Well, to find the vertex, we need to find the axis symmetry. Great. To find the axis symmetry, what do we need? Well, that would be the x-intercepts. So with our x-intercepts, or zeros, ones that were given right here, we can find the axis symmetry. You can use the axis symmetry to find the optimal value. Then you've got your vertex, and you can find vertex form. So it's going to take a lot of work, but we're going to go through it here. So first thing I'm going to do is just move this out of the way. Okay. So with these x-intercepts of negative 3 over 7 and 1 over 2, okay, I'm going to work with those to find my axis symmetry. So there's my zeros down here. Okay, so vertex form. So these are my x-intercepts. So I can find my axis symmetry by adding them together. So x equals negative 3 over 7 plus 1 over 2. So we add them together and divide by 2. Okay, so we should be comfortable working with fractions by now. So this will give me, if I find a common denominator, negative 6 over 14 plus 7 over 14, all divided by 2. So that will give me 1 over 14, all divided by 2, which gives me 1 over 28. Not a very friendly looking axis symmetry at all, but it works. Okay, so that gives me the axis symmetry. I need to find the y value of the vertex, and we did that before back in Unit 3 when we first started looking at quadratics. We find the optimal value, the y value of the vertex, by putting the axis symmetry into the equation for x and solving for y. Now we actually have two different forms of the equation we can look at. You can choose which one you think is easier to work with. Personally, I think that factor form is easier to work with, so I'm going to use that one. If you think standard form is easier, feel free to work with that one. And we should wind up with the same answer in the end. So I'm going to have y equals, I'm going to take my factored form right here, okay, and replace every x with 1 over 28. Okay, and again, the fractions are very ugly here, but I know we're good with fractions by this point. So 7 times 1 over 28 is 1 quarter plus 3. Sorry, I made a little mistake here with my brackets here. It's only the 2 that multiplies in that 1 over 28. I put an extra bracket where there shouldn't have been one. So 2 times 1 over 28 is 1 over 14. And again, just keep plugging away. I know it's fractions, and we don't always like fractions, but they are just normal numbers. The idea is still the same. So we get 1 over 4 plus 3, which when you go through that is going to be 13 over 4. Okay, and 1 over 4 minus 1 will give you negative 13 over 14. Okay, so we multiply all these together, so it's negative 2 over 1 times 13 over 4 times negative 13 over 14. Okay, multiply our numerators together, we get 338, not friendly at all, over 14 times 4 times 1, which is 56, which we will reduce down into, you divide both top and bottom there by 2, so you get 169 over 28. Okay, so again, our end result isn't very nice looking, but we have what we want, right? We have our vertex in the end. Okay, so our vertex has an x value of 1 over 28 and a y value of 169 over 28. And now we can actually start creating our vertex form equation. So we have y equals a bracket x minus h all squared plus k. So I can put in my h and k now. So I have x minus 1 over 28 all squared plus 169 over 28. Now, for this a value right here, normally we'd have to sub in a point to solve for a, just like we did with when we created factored form. However, one thing we saw on one of the earlier slides is that the a value from standard form and from vertex form are the same. So we've already taken the time to find standard form, so we know our a value there is negative 28. That will be the same a value that will carry over into vertex form. So we can just right away put in our a value as being negative 28. Okay, and we've got vertex form. Okay, and we can see our answer up there. Negative 28 bracket x minus 1 over 28 squared plus 169 over 28. Now, the one thing I want you to notice here, and again, we just talked about it, but the a value in standard form and vertex form are the same, but you wind up in this case getting a different coefficient, okay, an a value here of negative 2 in factored form. So just be careful. Don't just blindly take your a values from factored form and assume it tells you everything about direction of opening and transformations, because it's not going to necessarily be the same value in standard or vertex form. Okay, so after all that with ugly numbers, let's try one more with ugly numbers. And this will be the last example we'll do for today. And it'll just be finding the zeros of the quadratic defined by this one right here. So again, there's fractions in there, but I just want you to find the zeros. Okay, we found the zeros earlier with one from 2 examples ago. So what I'd like you to do is try this one on your own. Try and find the zeros. Remember that to find the zeros means the y value of the equation is 0 because it's the x-intercepts. Okay, and you need to find the x value that solves this equation. So I'll let you do that first. And when you're finished, push play, and we'll see the answers together. Okay, let's run through the steps here. Now, again, y is equal to 0, so I need to try to rearrange the equation, solve for x. So I added 33 over 8 to both sides of the equation first. So I got 33 over 8 equals 2 bracket x plus 5 over 4 squared. Then I divided both sides of the equation by 2. So when I did that, simplifying the left side, I got 33 over 16. Then I took the square root of both sides of the equation. Cannot forget my plus or minus here when we take the square root, otherwise I lose one of the solutions. And then I subtracted 5 over 4 from both sides. So I wind up with two possible solutions, one at the positive root of 33 over 16 minus 5 quarters, and one at x equals the negative root of 33 over 16 minus 5 quarters. So these are about as ugly looking x-intercepts as you could possibly get for an equation, but again, they're perfectly valid. They're just not nice looking. They're just not nice integers or nice fractions. Now, one thing I want to point out here, normally when we want to, if we were in standard form, if we wanted to find the x-intercepts, we would just simply try and factor it, put it in factored form, and then find our x-intercepts from there. However, we saw there were some equations that would be that wouldn't necessarily give you a factored form. So let's say if we look at this example right here, okay, and look at what this guy looked like in standard form, you can see the problem we run into if we tried to actually factor it. Okay, so I won't actually make you go through all the steps here, putting this into standard form, although it'll be a good exercise just to see if you're comfortable working with the fractions. I'll give you the standard form. Okay, so if you expand all this and put it into standard form, you get 2x squared plus 5x plus 1. I mean, it seems like a pretty innocent looking equation, considering the vertex form looks so ugly to start. But if you try to factor this one, okay, I'm going to get 2x squared minus 1. So I'd be looking for two numbers that multiply to negative 2, but add to 5. Okay, and there's no combination numbers that makes that work. There's nothing I could put into this array to give me a nice factored form. So we wouldn't be able to use factoring to try and get the x-intercept. So what we need to do is have it in vertex form and then do exactly what we did here. Set the equation equal to 0 and again, go through all the steps to solve for x. Now, how do we get from standard to vertex form is a different story. That's some other lessons coming up. But just keep in mind that sometimes we can't always factor something to try and find the x-intercepts. Okay, so that's it for today. I know there's some other examples in here. We'll do those next lesson. Just make sure you go through the practice here and become familiar working with vertex form and converting between some of the different forms that are out there. Okay, that's it.